morning, students. Today I am dealing with a subject called the air compressor for, which is part of a marine auxiliary machinery for the ships equipments, especially the importance of air compressor is understated. Okay. Now, without air compressor, it's one key equipment, the ship will be stranded because unlike the shore-based equipment like motor car, etc., which is started with battery, the main engine and the diesel generators on the ships is not possible to start with the battery. You need a huge amount of power to start this machinery because their power rating of these equipments are maybe in megawatts and kilowatts, which simply the battery power is not sufficient. So therefore, to start such machinery, we will be using air compressor, and that's one of the applications for on the ship to start the main engine and the diesel generator of the ship's power equipment by compressed air. Usually the power pressure range is 30 bar to 10 bar is the starting pressure for starting the diesel engine of the slow-speed, two-stroke engine of the main engine propulsion equipment. Okay. Now, as you see here, other purpose is that there are three important parameters on general basis to be control of the ship. They are pressure, the temperature, and the flow. The pressure and temperature are very common parameters that need to be controlled for various equipment. And flow is mainly required for flow control for controlling the flow of like steam flow in the boiler, etc. depending on the load demand on the boiler. Okay, boiler is going to run, boiler steam is going to run some steam turbine, so the flow, steam flow output should match the feed water inlet flow. So this has to match, and this equipment or valve are controlled by instrument air. So there, another application is your air compressor plays important role where pressure is reduced from 30 bar to 7 bar and 7 bar subsequently is reduced to 2 bar. So that's what you see in the general diagram that is shown in the previous slide. You can see there are three compressors filling in the two main reservoirs denoted with R, and then on the output side, this air is taken through oil filter to remove all the moisture and the oil content in the air compressor, and then pressure is reduced from 30 bar to 7 bar, and from after 7 bar, one tapping is for general service air for say, let's say your main engine nuts cannot be opened by human force. They have to open pneumatically, so there you use 7 bar pressure for opening the pneumatic nuts on the cylinder head of the main engine cylinder cover. Similarly, all the instrument air, which is controlling the flow, pressure and temperature for various systems such as jacket water system, low boil system, and steam flow, feed water inlet flow for the boiler, etc. They are controlled by instrument air, and this instrument air should be as dry and oil free. So therefore, this instrument air, before it reaches the consumer, that is the control valves, it should be passing through a refrigerated dryer to remove most of the moisture and the oil vapor. Okay. So this is another application of the air compressor requirement for the ship. Okay, now the basic theory behind the air compressor is that air is a gas, so naturally it has to obey the universal gas law, which is nothing but the pressure multiplied to volume is proportional to the temperature, proportional temperature. On the constant of proportionality that is shown there, that is called the universal gas constant. Universal gas constant. Okay, the units are specified there. Volume is in cubic meter, mass is in kilograms, and temperature in absolute temperature, that is degree Kelvin. Okay. Now, this gas law can be split into two: Charles law and the Boyle's law. Boyle's law only states that the pressure is inversely proportional to the volume, whereas the Charles law states that given a constant volume, the pressure is directly proportional to the temperature. So all these three important parameters, pressure, volume and temperature, they are interconnected in the air compression cycle. Now, usually when you draw a PV diagram, there are three important processes. One is called the polytropic process, another is called adiabatic process, another is called isothermal process. So these are these three processes through which a compression can take place to the point to initial, from the first point 1 to point 2 compression can take place by following either the isothermal process or the adiabatic process or the polytropic process. As you can see in the graphical representation of the PV diagram, you will see that the area under the isothermal curve is the least as compared to the adiabatic curve or the polytropic curve. Both the isothermal compression as well as the adiabatic compression, they are not practical. Really we can, in limited stages, we can approach these two. Adiabatic compression and polytropic compression or isothermal compression. Now, the normal compression we follow is polytropic compression, which is nothing but PV raised to n is a constant. PV raised to n is a constant. The index of PV, index of the volume n should be as least as possible. It should be between 1 and 1.4. The lesser is better because the work area under the PV curve will be less. So therefore, the compressor, which is a power taker, will not absorb too much power from the electric motor which is driving the compressor, or we can call the electric motor or some other prime mover like diesel engine. Okay. So the idea is that the work input is required for the compressor should be kept as least as possible. So therefore, your objective should be to follow the compression curve as close as possible to the isothermal condition. Now, as a human being, it's not possible for you to climb a single staircase right to the third floor without taking a break. The same way, the air compressor also, it's not possible to compress directly from atmospheric pressure to the final pressure stage, let's say 30 bar or 120 bar, which is usually for off-road drilling vessels, 30 bar usually for the ships. So it is not possible. So this final compression pressure can be achieved only in stages. So as you can see here, the PV diagram, in the first stage, the compression, as you see here, if you follow the polytropic compression, and because of the compression, there is heat is added, because pressure is proportional to the temperature. Because the given cylinder volume is constant, so therefore, the temperature is going to increase as you compress the air. So now, as I said, we have to approach the as close as possible isothermal curve. So after completion of the first stage, we resort to a stage cooling, which is called interstage cooling, as you can see there. So thereby, the area between the dotted line and the polytropic curve on the first stage, that is the amount of energy you are conserved, and that much work will be need not be needed from the electric motor. Similarly, subsequently, second stage also will start from the first stage, the delivery stage, go to the end of the second stage. Again, there will be sorting another intercooling, interstage cooling, and finally it reaches the third stage, delivery pressure. And from the third stage pressure, it will go to the air bottle or air reservoir. Okay. From there, the air will be consumed for the various applications which I have mentioned earlier. Now, the stage cooling, why it is required? One is to avoid excessive temperature rise associated with higher compression ratio and to approach the isothermal compression. What is high pressure ratio? High compression ratio? The ratio of the final stage pressure and the initial stage pressure, that is called the compression ratio. Advantages to this cooling is that, one is that compression work is reduced. Third thing is volumetric efficiency is increased, and hence the compressor capacity also increased. What is volumetric efficiency? That means the compressor is capable of drawing in more air by resorting to interstage cooling. Because as the temperature increases, volume also increases. So by cooling this volume, what happens is that you are accommodating more space for taking in more air. Okay? And thirdly, it is approximately isothermal compression. Okay. The next thing is that because of the less temperature, the valves, operating valve, suction valve, discharge valve, they will be cleaner. The amount of carbonization because of lubricating oil will be much less. Moisture separation is easier through intercooler drains because we all know that as the pressure increases, the saturation temperature also will increase for the moisture. If you reduce the pressure or cool down, the condensation temperature will come down and the water vapor that is there in the high temperature region will be cooled down and condensed into the drain pot from where it can be subsequently removed. Because this water, if it enters the compressor cylinder casing, it can be damaging. One thing, it will wash out through oil, and that is detrimental to the life of the compressor. So this is a basic single state diagram. As you can see here, everything is clearly defined, especially the V1 minus V4, that is your actual amount of air that is sucked into the compressor. Whereas it is supposed to draw in V1 minus V3. That is the normal air it should have sucked. So the ratio of these two volumes, that is defining the volumetric efficiency. Okay. And the capacity of the compressor is defined by the volume V1 minus V4 converted into standard atmospheric condition and defined in per hour how much it can deliver. Now, ideally, we cannot approach the piston cannot approach the top dead center because we need some clearance volume so that the piston does not bang against the cylinder cover. So some clearance is given there, which is called the bumping clearance. This bumping clearance multiplied by the area of the piston will give you the clearance volume, which should be kept as low as possible. Because the larger the clearance is going to affect your volumetric efficiency of the compressor, and compressor capacity is going to reduce. Okay. So generally ships use only a 2 or 3 stage compressor. For all practical purposes, 2 stage compressor is more prevalent as compared to 3 stage compressor, except for few applications like a breathing air compressor which is normally present on the ship. There are multi-stage more than 2 or 3 stages compressor where it will be compressed to the final pressure of the air, breathing air bottle pressure. Okay. So here there's one arrangement of air compressor shown cross-sectional view. As you can see, the smaller piston is the HP piston, and the larger piston is the LP piston. LP is low pressure, HP is high pressure. Okay. Now, the reason why HP piston is small is very obvious that you again go back to the gas oil, we see as the pressure increases, volume decreases. So the volume of cylinder for the LP stage is much less as compared to the LP stage where pressure is much less. Again, the components of this air compressor is something similar to diesel engine, reciprocating engine where you have crankshaft with the main bearing and then piston, and then similar to exhaust valve, suction valve, here we call it as suction valve and the delivery valve. So that is the only difference between the engine and the compressor, except that engine delivers power whereas compressor takes in power, absorbs power. So obviously for engine, the adiabatic process area and PV curve gives you more output as compared to isothermal process. So therefore, engine you prefer adiabatic compression, whereas the compressor you prefer isothermal compression. Both are impractical cycles. So therefore, both engine as well as compressor they will be operating only on the polytropic process. Here another arrangement. Here the HP piston and LP piston they are inline. So this is inline arrangement. So inline arrangement is there are two separate connecting rods operating HP piston and the LP piston respectively. Okay. There is another arrangement called the tandem arrangement. Here the tandem arrangement is single connecting rod is driving a single piston, and the single piston is a compound piston with a LP on the upper side and the LP on the lower side. Both are acting on the opposite direction. Through the air filter, air is drawn in the LP stage during downward stroke. And during downward stroke, as you can see, the annular space between the two piston diameter, differential diameter is here. The volume for compression for your LP stage. So, during downward stroke, suction valve will open on the LP side. At the same time, delivery valve on the HP side will open and pass through the aftercooler and go into the air bottles. Okay, similarly, in upward stroke, the LP stage will be delivering the air through the intercooler to the HP suction valve. So both are operating in the opposite direction. That is what we are seeing is a two-stage compressor. Here, another arrangement, but this three-stage compressor, again same tandem arrangement, a single connecting rod is driving a compound piston which is consisting of a HP piston, a LP piston, and followed by an intermediate piston. The explanation is same, similar to the two-stage tandem piston. Here, during downward stroke, the HP stage suction valve will open, the second stage, intermediate stage, delivery valve will open, and the suction valve of your LP stage will open. Delivery valve of the suction valve will open. Okay, both will pass through the intercooler and the aftercooler to the final stage, and from the final stage it pass through the aftercooler to the air bottles or air reservoir. Okay, some requirements are very essential for the ocean-going ships. What are the essential requirements? Every ship should have two main air compressors, and these are powered from the main switchboard. And each compressor should be capable of pumping from 15 bar to 35 bar within 30 minutes. 30 minutes usually it doesn't take that much long. Usually it takes 15 to 20 minutes for a highly efficient compressor. Okay. And another requirement is that the capacity of each air reservoir should be such that the combined together, they should be able to give a total start for a slow-speed diesel engine, which is reversible, whereas for a non-reversible engine, you should be able to give at least 6 starts. Usually during the ship trial, without filling the air bottle, air is consumed in the air bottle, and from my experience, I have seen at least you can achieve 16 starts on a slow-speed diesel engine. That is from 25 bar to 10 bar. Up to 10 bar is the least air pressure at which a main engine, slow-speed engine can be started. Okay. When the power fails, now the main air compressor becomes useless. So therefore, you should have a backup arrangement in order to recover from a blackout condition or a dead ship condition. So therefore, you have an emergency air compressor, which can be either a diesel driven or an electric motor driven. If it is electric motor driven, where is the power coming from? For the electric motor. So usually you have an emergency switchboard which is powered by emergency diesel generator to supply power to the emergency air compressor. Okay. So that's the way you recover. With the emergency air reservoir, you fill up with the emergency air compressor, then you start the main generators, energize the main switchboard, then power the main air compressor to refill the main air reservoirs. The third requirement is each of the air compressor should have a bursting disc on the casing, cooling casing, so that in case the air coolant bursts, the casing should not be subject to the air pressure, which can be either 25 bar or 5 bar, which is more than the normal working pressure of 3 to 4 bar of cooling water pressure. Okay. Then each compressor should have a safety valve designed so that in case of accidental closure of the outlet valve, the compressor should not get damaged. So, if it exceeds 10% of the maximum working pressure, the relief valve should lift and relieve the pressure. Okay. The fifth one is the air compressor cylinder covers, intercoolers, and aftercoolers are tested hydraulically to twice the working pressure. That is, the air cooler tubes through which air is passing should be subjected to twice the pressure. Tubes should be tested to twice the working pressure. Whereas the casing of intercooler and aftercooler should be subjected to 1.5 times the working pressure. That is, if it is 3 bar pressure, it should be subject to 3 multiplied by 1.5, 3 by 2. If it is 4 bar, 4 into 1.5, that is 6 bar pressure should be tested. Okay. A water separator is given to remove all the condensed water from the each intermediate stages during compression. On this manual operation, generally automatic operation is not given except for unloader. Because all compressors will have to be started in unloaded condition and stopped in unloaded condition. So these are the important components of the air compressor. You cannot miss out any of these 8 components that are listed here. All of them are very, very important. Each of them have an important function for the operation of the air compressor. Filters, it prevents the dust from entering the air compressor cylinder. Valves are required for pumping this thing, closing and opening. Piston and tank shaft and bearing, they are the supporting equipment. Piston undertakes compression and suction. Okay. Intercoolers, aftercoolers are for cooling purposes and making the cycle of the compression as close as possible to the isothermal curve. Air filters usually is a mesh filter which is soaked in oil and oil is drained out, and this oil trapped mesh will filter out the dust particles from the air. So here we have a simple sketch, a simple blown-up view of the actual HP wall, HP wall, delivery wall, the suction wall is shown here. The arrangement is almost same. If you invert it, it will become a suction wall. If you keep it upright, it will become the delivery wall. Okay. This is an examination sketch for HP wall and the suction wall, and the suction wall and the discharge wall. So here some material that is applicable for this valves is this wall disc is made of nickel steel, whereas the springs are made from spring steel, and your wall seat is made from 0.45 carbon steel. It is hardened and polished. Intercoolers, aftercoolers, the tubes are made up of copper and casing is made up of cast iron. Okay. In the cooling medium is usually fresh water. You attach cooling water pump for circulating water through this cooler. And it's very important that this cooler casing should have a safety feature, that is the bursting disc. Unloader, a compressor during the starting and stopping must be in unloaded condition. This reduces the starting torque, that is starting current for the motor. Also, it clears out any accumulated moisture and dust. If the compressor is required to be running continuously, it has to be unloaded periodically after the reservoir is filled to the full pressure. Okay. This small sketch about unloading throttling suction side. Here another arrangement from unloader where the suction wall is depressed, so that the compressor will not pump. It just simply pump in and pump out. Usually a pressure transfer is fitted onto the delivery side, and that it is operating in such a way that the compressor will start with a low pressure, desired low pressure, and it will cut off at when the required pressure stage is reached. Frequent start and stop will damage the compressor and the motor. After all, the compressor is not meant for a continuous operation. It has given rest in between compression and operation. There are safety features that is provided on the compressor. Compressor moving parts are lubricated, so we have low boil pump. When the low boil pressure is low, you will first get alarm, then the compressor is locking by cutting off. Similarly, air temperature, high temperature alarm will come first, then it will cut off as a safety feature to protect the compressor from damages. The relief wall arrangement is shown here. Very simple arrangement, simple meter wall like thing. Very simple sketch. The spring-loaded wall, it will open at the desired pressure. For an LP stage, it should be 1.5 times, and for the HP side, it will be 1.5 times the HP pressure. First, this is based on the pressure and the temperature. Compressor lubrication, you lube oil pump driven by a chain drive. You can see at the end of the crankshaft the lubricating oil pump and the cooling water pump. The fusible plug is a very thin sheet metal which is thus at the required pressure. It is tested before fitting onto the compressor casing. Also, the temperature is 121 degrees centigrade, the fusible plug will melt off and relieve the pressure. Some operating problems, the compressor not functioning properly, these are some symptoms. Either the inner side is choked, or the compressor valves are leaking, or there is too much of LP bumping clearance, or the piston rings are leaking, or the cover gasket is leaking, the drain valve is not shut off, unloader is not shut properly. All those some of the symptoms which can affect the performance of the compressor. The effects of wall leaking is that first stage suction will reduce capacity and first stage delivery will be very high. And if HV suction wall leaks in the HP stage, you will find the LP pressure is rising and second stage delivery pressure is decreasing. So this is some practical PV diagram for the compression cycle. These are the effect of leaking valves. The dotted lines are the effect of the reduced air delivery. Maintenance, it goes without saying that preventive maintenance is the correct approach, and carrying this out properly, it is essential to maintain the main air compressor periodically. You have to refer to the manufacturer's manual, what are the intervals at which the compressor should be maintained and overall. So on a daily basis, the performance of the compressor should be observed and logged in the logbook. Okay. Safety, before commencing any maintenance, it is essential that compressor power is put off and all the precautions are taken that the compressors are isolated other parallel compressors so that no accidental damage can take place to the personnel. Lubricating oil, the correct lubricating oil should be used. Some ships will be using, some compressors they use synthetic oil, some compressors they will be using the mineral oil. So please refer to the lube oil chart on your ship, which is the correct grade of lubricating oil that is meant for a main air compressor. Okay. So that finishes the presentation, and I hope this topic on the compressor is understood. Very important piece of equipment. Without the air compressor, the ship will be handicapped very badly, very badly. Okay. Thank you very much. Any doubts, please?